So this question involves acceleration. It says that the acceleration of a car, acceleration, which we're going to label as A, is equal to 1 over 40, 60 minus V, meters, seconds to the negative 2. You can also rewrite this as a fraction. This should be meters per second squared. Okay. In which the velocity v is equal to v meters per second. It says meters per second squared, but it really should be just meters per second, not meters per second squared. I think that's a typo. It's now asking that the car is starting from rest. So we interpret that the car starts from rest, meaning that when t is equal to 0, it means v is equal to 0. So we can rewrite that actually as v of 0 equals 0. In fact, I can rewrite a and v. I'm going to put parenthesis t next to them to show that these are functions of time. That is, time is going to affect acceleration. Time also affects velocity. And so when time is 0, the velocity will equal 0. Okay? And what we need to find is the velocity of the car after 30 seconds. So we're going to replace t with 30, and we need to know what the heck that value is. Now, the key to answering this problem is understanding that acceleration is a derivative of velocity. That is, acceleration is the change in velocity divided by the change in time. So we can rewrite at as dv over dt. Okay, we interpret this as the derivative of velocity. The d's meaning change, right? So the change in velocity divided by the change in time. And this is going to equal 1 over 40, 60 minus v. Now, to solve a differential equation, we need to integrate. In order to integrate properly, we need to get all of the same letter on the same side of the equation. What I mean by that is, notice on the left side, I have a v and a t here. Those are the two different letters that we care about. We don't want them on the same side. We want them on different sides. So we're first going to multiply both sides by dt. Okay? So what will happen is this dt will cancel out with this dt. Now, on the right side, I have a v here, but it's matched up with a t. I don't want this v here, so I need to move this v to the other side. So I'm going to divide both sides of this equation by 60 over v. Or divided by 60 minus v. I'm sorry. Okay. I'm running out of ink for this red one. Let's throw that aside. Let's go with green. All right, that's prettier. So we get 1 over 60 minus v dv, which is equal to 1 over 40 dt. Once we have this situation, again, dv with v, dt's with t's. Well, we have no t's here, but this is fine. Once I have this situation, I can now integrate both sides. Right? Now, the integration on the left, I see that I have 60 minus v in the denominator. That tells me if I'm integrating, I should turn this into a natural logarithm. So this should become the natural logarithm of the absolute value of 60 minus v. Now, I want to double check that if I take the derivative of this expression, I should get 1 over 60 minus v. If I take the derivative, I will get 1 over 60 minus v, but because I have this negative here inside, there would also be a negative on the outside because of chain rule. So in order for that negative to cancel, I actually need to put a negative on the outside. So the integral of 1 over 60 minus v will actually be negative natural logarithm of the value of 60 minus v. Okay? For the right side, the integral of 1 over 40 is with just 1 over 40 times t. Because these are not definite, these are indefinite integrals, we're going to have a constant that we need to figure out. Okay? Right. Now, how do we figure out this constant? Well, remember, we still have this piece of information that when t is equal to 0, v is equal to 0. So what we're going to do is we're going to substitute t is equal to 0 and v is equal to 0 into this equation, and we can solve for c. So we're going to get the negative natural logarithm of 60 minus 0 equals 1 over 40 times 0 plus c. Well, this is going to go away. This is going to go away. And so we end up getting c is equal to the negative natural logarithm of 60. Okay? So if we rewrite this equation, we're going to get negative natural logarithm of 60 minus v equals 1 over 40 t minus natural logarithm of 60. Now, what we need to do is we need to get v by itself, so then we can finally plug in 30. Okay? We're going to need to divide both sides by -1 to cancel out the negative. I realize I am running out of room. Natural logarithm of absolute value of 60 minus v. These can switch around, so we're going to get the natural logarithm of 60 minus 1 over 40t. Okay? Now, this natural logarithm, how do we get rid of that? Well, a logarithm is basically an exponent. So we're going to actually put an e down here and put these pieces as exponents. What's going to happen is this natural logarithm and the e are going to cancel out. So we're going to get 60 minus v, absolute value. And now something weird happens here. Because I'm subtracting with an exponent here, if we use our exponent rules, this should equal e natural logarithm of 60 times e to the negative 1 over 40t. All right? Using our exponent rules again, this e cancels out this natural logarithm. So this will just equal to 60. Okay? So then we get the absolute value of 60 minus v, which is equal to e to the negative 140t. Okay? We're just going to go ahead and assume that this will always be positive. Okay? And if we add v and then subtract, I'm going to move this up here. We're going to cheat. Sorry about that. We are going to get v is equal to 60 minus e to the negative 1. Oh, sorry. Let me make sure I get this right. 60. Hold on. Totally forgot something. This should be 60 times e to the negative 140t. So isolating v, add v to both sides, subtract this thing and move it to the left. I should get v is equal to 60 minus 60 times e to the negative 1 over 40t. Okay. So this is my value for v. Now I can plug in my 30. So v of 30 is going to equal 60 minus 60 times e to the negative 30 over 40. Right? Minus 60 e, and this just comes out to negative 3 over 4. So this is your value of v30. Thank you so much for watching. If you like what you saw, please click the thumbs up button. And if you want to see more of my videos, or you want to ask me a question on one of my office hours live streams, please click subscribe to Sophos Tutor.